Let's talk about circuits here real quick. So first off, we need to know some symbols. This symbol right here is what stands for a cell. You might say, what's a cell? A cell is the true version or true name of what we call a battery. And so right here, this longer side stands for the positive side and the shorter side stands for the negative. Remember, we say that the current flows from positive to negative. So if you put a bunch of cells together, you'll get a battery. And that is technically what a battery is. It's a collection of cells. So your double A's, your triple A's, and your D's, those are all cells. They're just actually two plates of metal in there. But your 9 volts actually a battery. It's a collection of different cells inside of it. So this symbol right here is a resistor. It slows down the flow of current, and either of these symbols is a bulb. We're going to focus in on this one right here. So rather than draw this actual diagram with a battery and a switch and these bulbs, we can save ourselves some time by using the symbols for them. We call this a circuit diagram. So these two things are actually the same. This one tends to be a little bit easier to draw. Here's our bulbs, there's our switch, there's our cells that forms a battery. This, by the way, is called a series circuit. A series circuit is one in which there's just a single pathway through the circuit, only one pathway for the electrons to flow. It can't divide up at all. There are 5 great rules to series circuits, so let's talk about them right now. The first one is that the current is the same everywhere in a series circuit because there's nowhere for it to branch. If we want to write that in equation form, we could say that the current coming out of the battery is the same as that goes through resistor 1. That's what I1 means here. It's the same as the current that flows through resistor 2 and the same that flows through resistor 3. So all of these currents right here, including the current through the wire, they're all the same value. They're the same current here. So our second rule of series circuits is that the equivalent, which is a fancy word for total resistance, is equal to the sum of all the individual resistors. In equation form, we could write it like this. The equivalent resistance is equal to resistor 1 plus resistor 2, plus resistor 3 if there is one, and so on if there's more than that. So you can see a few quick examples here. 2 6-ohm resistors is the same thing as 12 ohms. Just add them up. 3 6-ohms would be 18 then, and 4 6-ohms would be the same thing as 24. We simply add them up. So you try a quick one here. A 6-ohm and a 4-ohm in series would be the same thing as a 10-ohm. Just simply add the two resistances together. The third rule of series circuits is this. The current that comes out of the battery and therefore flows through the whole circuit, we can use Ohm's law to find that. Ohm's law says current is equal to voltage divided by resistance. It's important that we use the total, the equivalent resistance. So let me give you an example. I'll come back to this one later on this page. We have a 10 ohm, a 20 ohm, and a 30 ohm resistor in series. First step we have to do is find their equivalent resistance by simply adding them up. So 10 plus 20 plus 30 gives you 60 ohms. Second step is we use Ohm's law. Current is equal to voltage divided by total resistance. So 12 volt battery divided by a total of 60 ohms gives us 0.2 amps flowing out of the battery and therefore through the whole circuit there. Our fourth rule is this. Ohm's law can then be applied to each individual resistor. We say that there is a voltage drop across each resistor. We're going to use Ohm's law in this form this time. Voltage across resistor 1 is equal to current times resistor 1. So let's give an example of that. Let's use this guy we just talked about. Our current, if you remember, we just solved for was 0.2 amps. We're going to use Ohm's law in this form. Voltage equals current times resistance. So in this form, we say voltage, 0.2 amps is our current, times a 10 ohm resistor right here, gives us 2 volts. The negative means we drop 2 volts right through there. We use up 2 volts of our total voltage of the battery. Let's apply it again to resistor 2, 0.2 amps times 20 ohms in this case gives us 4 volts. We have a 4 volt drop across that resistor. And applying it to resistor 3 here, 0.2 amps times 30 ohms is 6 volts, a 6 volt drop right there. So our fifth rule comes from this. What is 2 volt plus 4 volts plus 6 volts? It is 12 volts, which is the voltage of the battery. So that leads us to the fifth rule here. The voltage of the battery always equals the sum of the voltage drops across each resistor. So in this case right here, we have a 3 volt, a 7 volt, and a 2 volt drop, but that adds up always to the total voltage of the battery. And it has to, and we'll come back to that in part 2.